Okay, so let's look at some role-based security. As we'll see, role-based security allows us to be able to easily lock down our applications. So with this, what we tend to do is that we tend to identify users and then link these to their role. So in this case, Bob has an administrator role. He might also have another role, such as part of engineering, say, and the rights that he gets depends on his role and not necessarily from his ID. And then we can have roles such as guests, which will have limited rights on the system. So when we deal with a web-based application, the main types of authentication that we can then get based on a role-based authentication are built-in windows, where we can get the local Windows registry to authenticate a user. We can get passport-based authentication, such as from Windows Live Passport. Form-based, where we can authenticate a user by them entering a username and password into a form, and then integrated IIS authentication. So too often our applications themselves do not take role into account, and that they often sit alone. As much as possible, we need to understand the role and the identification of the user to enhance the overall security. So the main interface that we have is called iPrincipal, and from this we get the Windows Principal class, and this allows us to be able to create an ID for a user. So in this case we have Windows Identity, and we use the getCurrent method, getCurrent, and this will give us our ID. We can then define what the identity is, the name, how it's been authenticated, and then we can actually define whether it is a built-in role, such as an administrator. So the main types of tests that we can have is an anonymous user, have they been authenticated, are they a guest, are they a system, and system account, and so on. And then some of the built-in roles that we have are administrator, guest, power user, and so on. So if we have a little look at an example, and our main example here is integrated into an ASP.NET page, and it's Security 11. So we'll just go back to Visual Studio and find this one. It's in here. So if we find Security 12, we just set that up as the default page, just to test. Let's check. Security 12, Security 11. Okay, so in this case we'll enter some basic details. We'll get the current identity. Because it's running from the web server, it's likely to have a delegated role. So we'll just set this one up to be the default starting page, and we have a look at the code. that we have behind it. So we get the Windows identity, get the name, authentication type, and then we can then use this to decide is the user an administrator. So as I said, some of the roles that we have are guest, power user, and so on. If it's an administrator, then it will show you're an administrator. If not, then it will say you're not an administrator. So we'll run this example. And then what we should see is the role that we have actually on the web server. So we can do the same for any Windows program. It can run in the same way. Just takes a little minute to load up first time. Should get there eventually. Okay, so we can show the role, and we can see here, here's my ID, this is my login. It is coming from the local Windows identity, and it says that I'm an administrator. So .NET has a strong and integrated security model which is scalable across corporate infrastructure. One of the problems that we have with our system components is called DLL hell. With this, new components can be saved in a place that has existing DLLs, and thus a previously loaded DLL might look for a certain version, a previously loaded application might look for a certain version of a DLL. If a new one comes along, then it can overwrite the existing one, and it can cause our existing applications to crash. .NET tries to overcome this by giving each of our DLLs and our components and assemblies a unique name. This is defined as a strong name and uses a cryptography function and digital signatures to be able to uniquely define our assemblies. And it overcomes DLL hell. We can see here an example of our global assembly cache, and we can see that there can be multiple versions of an assembly inside our global assembly cache. And then if we have the same version, then we can have different signatures for each of the assemblies. To generate the strong name, we need what's called an SNK file, and this holds a public and a private key, and it is up to these keys to be able to sign the assembly to give it a unique name. In this case we have a text name, a version number, a public key, and a digital signature. To generate our public key pair, we use the SN utility -k, and we generate an SNK file. Once we have that, we can then add this into our assembly and sign it. So in this case we see an example here of an assembly, and it has a certain public key token and a version number. When we integrate this into our components, we then add our SNK file. So if we just try and find an example of this from here, see. Okay, so in here we should find that we can add in our SNK file into our assembly key file. Okay, before we look at the .NET security model, we'll look at an example of how we can register a DLL into the cache. Oops. Okay, so here's an example, and we'll just build that, and then this should create a DLL for us. Okay, so that succeeded. Just a very simple DLL. It has two methods, multiply and divide, in there. And now what we'll do is that we'll register this into the global assembly cache. So the DLL we have is here. And then we can use the global assembly cache util to register the DLL into the global assembly cache, and then we should be able to find it in there. So once it's in there, then all the applications within inside the machine can actually get access to it. Okay, and have a look at the .NET 2 global assembly cache, and it should be in here, and we should be able to identify the unique name for it because we signed it with a strong name. So if we just look down, we should be able to find it in here somewhere under my math. And here it is here. So we can see here it has a certain version number that we've actually given it, and here is the public key token here, and the version and the public key token along with the assembly name should be able to identify the assembly correctly. So let's have a look at the .NET security model. So it is built around a hierarchical infrastructure where we have a global enterprise security policy, then we have a machine policy, and then eventually we have one built around the user. So with this we have XML files which define each of these. So for the security configuration, we have enterprise security.config, and then at the machine level we have security.config, and then at the user level we have a more refined security level. Along with this we have web.config for web applications and app.config for Windows versions. And this allows us to customize the security of either web or Windows applications. So the user policy is so the .NET security model is built around enterprise, machine, and then user. So the highest level is enterprise, the next level down is machine, and then the final is user. The main .NET configuration policies are typically saved within inside the framework folders. So in this case we can have a little look. So this is an example for .NET 2.0. So we can see here there are a number of config files. So we can see in here enterprise, machine, and security. There's also a web.config in here. We'll see how that's used later. If we look at the enterprise one, then within inside here we can see a number of XML settings that we have for .NET. So the machine tends to store multiple versions just in case there is a problem with one, so that the system can backtrack to a previous one. The main focus for this part of the presentation is on the web.config file, and as we'll see, this is an important file for defining the security levels for our web-based applications. For this we have a special file called web.config, and this has an XML format and defines many of the security features for our web pages. The web.config will then control all those web pages within inside a certain folder. Any subfolders, the web.config within those folders will actually define the security for those folders. So obviously we don't want users to be able to view this file, so when they do try to view it, it should give some form of error. If we have a look on our own web server here, and inetpub www.root, and we should find that we have a web.config file here. But then when we actually try to access this file, then hopefully we should get some form of error. There are a number of tags that we see inside the web.config. These include authentication. This defines how we're going to authenticate to the user with a form or with Windows database, user database. Authorization is who we authorize, and other things like compilation. We can have a debug flag to show debug information or not. So we can have authentication mode of Windows, and that will check the local user database to see if they have a valid account, or we can use forms where we can redirect the user to a form to log in to. It's also possible to use a password to get a single logon and to profile from member sites, and of course we can get an authentication of none. So let's try a simple example. So in this case we'll take a default page such as this one. Okay, so what we'll do is that we'll set that as the home page, and then we'll go to our web.config, and we can see here the authentication is set. So it helps us to write these tags. We'll say none initially. So now we should be able to go straight to that page and access any other page within inside this local website. Just takes a little minute to start up, and we can see here this went straight to the page. It's just initializing, but it should load up. And what we'll do next is to modify the web.config file so that the user cannot get straight into this page. Just takes a little minute. There we go. So everything's worked fine there. So now what we'll do is that we'll make sure, we'll come back onto the Windows authentication later, but we'll uncomment this out. And we'll take this one, put it in there, and we'll take this one and put it there. Okay, so now we have authentication of forms. We do not allow any guest users. If we go back to our presentation, So with our authorization, we can deny certain users or allow or deny certain roles. If we have the question mark, it's the anonymous user, and the star identifies everyone. So in this case, we will not allow anonymous users in, so every user should go into the form. So the form that we're loading up is login.aspx, protects all the files. So then we'll just have a look at that. Okay, so we have our code here. We'll just look to see what we have. So this will take the username as the username from the form, and also the user password, and feed it into the password. So only when the two actually match will it be successful. Okay, so now what we'll do is we'll just stop debugging. We'll now run the file. Hopefully the web.config file has been saved. So now what should happen is that we shouldn't be able to get access to any of those files, and we should get a login. So let's went to them. If we try the wrong username and password, shouldn't allow us in. Now what we'll do is we'll enter Fred, and the password for Fred is pass1, and that should allow us in. Okay, so we should be able to, once we've signed in once, we should be able to access any other of our files. So we can see here the web.config file has allowed us to get access to define the usernames and passwords. If we made this a star, then no one would allow in, because it says deny all. If we made it just for Fred, then we could deny just Fred. So there are various other tags that we can actually use with inside here, and we can define an impersonate. If the impersonate is set as true and the authentication is for Windows, then our Windows identity gives, and the other HTTP identities give us the domain and the username. If we say the impersonate is false, then we can see here that the Windows identity gives the ASP.NET name, which is the name of the user who is running the ASP.NET machine. So we can see in this case, when it was set to true, then that user is being impersonated by the user who has logged in. So let's look at the infrastructure that ASP.NET provides. So at the start we have a client, and the client will then connect into a web server. The web server itself will be running as an IIS service, which is built upon on ASP.NET. Then we can have various ways that it can integrate with a middleware service. It can either be built around web services, or if speed is required, then it is often built around .NET remoting, which allows the call to DLLs, or for a robust enterprise environment it might also involve the integration of COM+ components. Then we can have our back-end database server. Along with this, we have some secure communications using SSL or IPsec to make sure the complete conversation is secure. So we have authentication of the clients of the applications. Then we have authorizations, and that's the access controls that are required for the clients. And then we have secure communications. So the two main methods for integrating our middleware is to use .NET Remoting. With .NET Remoting, we have DLLs distributed around our system. We have some sort of listener which is waiting for calls, and then in .NET we have a local proxy where the client communicates with the proxy, and the proxy then communicates with the remote components. For a web services based system, this tends to be slower but is more compatible on a range of systems. Again, we have a local proxy, and the client communicates with that proxy, which then communicates with the web services. We can also have a COM+ type environment. In this case, this is an example of a COM+ component or a service component, and this is added in as a COM+ component to our system. So at the first level, we have our IIS security. So one of the advantages of a web-based approach than a normal Windows type infrastructure is that we get the IIS security built into it. So the levels that we can have for this is anonymous authentication, basic, digest, integrated, or certificates. And with the authorization, we can get normal NTFS permissions or IP restrictions. So if we have a look at our web server, settings, control panel, and administrative tools, and then IIS. It takes a little minute to start up. Okay, so this is the Vista version. So we can see here that we have our web server running, and we can stop it if we want. It's running for both port 80 and port 443 for secure communications. So with inside our IIS, we can have a look, and we can see here that at the present time we have anonymous authentication. So if we go back to our Visual Studio application, here, and we'll make it Windows authentication. We'll just comment this right out. To them. Okay, so now if we have Windows, let me just save that. Now when we run it, the IIS has defined anonymous login, so it shouldn't ask us for any logins, and should go straight to the page. It just takes a little minute to start up. Obviously it would be much faster if it was running from the local web server, and it should get there eventually. There we go. Okay, so now what we'll do is we'll actually go to the proper server. So we look at our web.config file and we'll find our authorization. Okay. Just run the web server. Okay, so everything's worked fine there. So now what we'll do is that, so it's purely using Windows to authenticate, and if we look back at the config of IIS, then we had Anonymous enabled. So we'll disable it, and now what will happen is that we'll get basic authentication. So now we'll disable, just make sure that we have that set. So we've set it for basic authentication. And we have Windows here. So now when we access our web server, we see here that we get a login. So if we get that incorrect, if we don't have a user called this, then we should be able to get access to our page. And now what I'll do is I'll log in with a valid local username, and it allows us to get in. So you can see what's happened there, and that because we set this to be basic, then it will use the local Windows database to authenticate the user. The only problem with this is that the username and password is set in a plain text format using base64. If we use digest, it makes a basic hash of this. Okay, so we've seen there that we can actually apply the local database to provide the authentication. So Anonymous was no authentication, basic is in base64, digest is better because it has a hash signature, integrated allows us to integrate with a Kerberos type infrastructure, and certificates uses a digital certificate infrastructure. Okay, so we've seen that when we set up, we enabled the anonymous authentication and it allowed us in without any usernames and passwords. Then we changed it to basic and we needed a valid local username and password. With our NTFS permissions for the www root folder and other folders, we can actually set the permissions locally. Then we can set IP restrictions on the actual connections that we get. Okay, so we can actually add them here. So let's say that we want to allow all of these addresses. And that is defined in our IP restriction. So in this case we can lock down our website to only machines that we trust. At the next layer we see enterprise services, and with this we have authentication using the RPC protocol and the authorization using COM+ roles and also NTFS permissions. Then for SQL we can have Windows authentication or SQL authentication, and with the authorization, logins, object permissions, database roles, user roles, and application roles. What we've seen before was the impersonate equal to true, and with this we can access a local resource by impersonating a user. With delegation, we are allowed one hop to access a remote resource.